flow. So simply, internal flow means this is the flow will go inside the pipe. External flow, it could be two things. Let's say this is a flat plate, okay, and the fluid is flowing in these directions. So we can say it is parallel to the flow directions. Like this is the plate and the flow is going this way. So in general sense, we know it will be kind of like this. The flow, it will go like this because the flow over a flat parallel flat plate. If this plate, if we put it in the vertical directions like this, so there should be different orientations. So like say this is another plate, it is in the kind of the vertical directions, but the flow is going like this way. Okay, so what we can, in other words, we can say this is a blunt body. In general sense, we can say this is a streamlined body. Blunt body means some objects, it actually block the airflow. So when this will hit, this is 5 different, the fluid is streamlined. You see when it is hitting this, you will see what will happen. Fluid cannot actually cross this vertical plate, but what would happen is it will go like this, isn't it? So the flow will separate here. So the flow separation is happening here. It will create some sort of recirculating zone at the way in this section. So what actually happened when we have a object, this kind of solid objects, it could be this shape, it could be a sphere, or it could be a cylinder, whatever it is. So fluid is passing this way. When the fluid flow, it will pass a solid body. Naturally, two things happen there. So one is some pressure. Okay, pressure will act on this along the normal directions. So what will happen here? Some pressure force, it will act along the normal directions. That means you all know pressure always acts in the normal directions. It makes 90-degree angle. And the another force is due to the viscous effect, we will have some sort of shear force. It will act through the flow directions. So I said two things. You just try to understand here. One is the pressure force, another one is the shear force. For every cases, when fluid try to just overcome a solid body, any types of solid body, we will get two types of force. One is the pressure force, it always acts to the normal directions, and the shear force, it acts to the flow directions. And depending on the structure of the body, this force, with the change of the directions, this force, it could change in different section. I mean, the local pressure of the shear force could be different. When we will analyze the external flow, we will not consider the local change of this pressure or the shear force. We will be looking for the resultant or the total pressure force and the shear force which is acting on that solid body. I'll go back here. So if this is a circular cylinder and if the flow is just going this way, so I said we will have the pressure force like this way and the shear force this way. We said the combination of these two forces, the pressure and the shear, the combination of these two forces, you can say this is all about the external flow. And sometimes we will say the pressure force plus shear force, this is drag. Sometimes we will say this pressure and the shear, it is lift. So it is confusing, isn't it? So I said we'll say sometimes it is drag, sometimes it is lift. So when it is drag is the force when it will act through the flow, along the flow direction. So if this force, pressure or the shear, if it acts to the flow directions, so it will be the same direction. So let's say the fluid is going this way, and if we get this sort of force in the same, it could be kind of parallel, it's not in the parallel direction, then we can say this is drag. And when it acts in the upward directions or the perpendicular directions, then we will say this is lift. So this is the simple one. If it is the flow directions, so we'll say, okay, the upward force, we'll say this is the lift, and it could be like this too. It could be in direction, so the parallel direction force, we'll say this is drag. I'll explain it. This is whatever I'm telling. This is something so abstract definition. Now let's think about the